Hey guys, Mr. Mackey here. Now yesterday I was introducing you to factorising, and today I'm going to show you how we can use factorising to solve equations and find out what x actually is. But for now, we're going to go over the challenge I set you yesterday, which was to factorise this equation. So what we have to do is, firstly, are we doing anything to our x? Well, no, because it's still x squared. So we have an x here and an x here. Now we need to find two numbers that when multiplied together gets us -9, but when added together gets you 0. So let's think about it. So two numbers that when multiplied together to get 9 are 1 and 9. So if we had -9 and 1, they do get -9, but added together gets us -8. That can't work. What about -1 and 9? Well, multiplied together gets you -9, added together gets you 8. Can't do that either. What about 3 and -3? Well, 3 and -3 times together gets us -9, and then 3 and -3 gets us 0. So how we completed the brackets would be x plus 3 and x minus 3. If you put it as the -3 there and the +3 there, that's absolutely fine. But those are the two values you should have used to complete the factorising. Fantastic work. Now, factorising is used to solve quadratic equations and find x in them. If the equation wasn't quadratic and we only just had an x, then you could just do balancing or flowcharts to find our x value. But factorising is how we actually find it in this sense. Now, the first thing we need to do whenever we are solving a quadratic equation is we have to make sure that everything is on one side and 0 is on the other. That's because when we're factorising, we are going to be including every value in that factor. So, is it the case for this? Well, we have x squared plus 5x on one side of the equation, and we have our 0 on the other side. So step 1's complete. We have got everything on one side and a 0 on the other. Now we factorise. So what does x squared plus 5x have in common? Well, they both have x's in them. So we have our x, then in our brackets we have our x plus our 5, all equaling 0. Simple. Now, whenever we're doing quadratic equations, so ones that have an x squared as the highest indice, there'll always be two different values of x. In most circumstances. There are some that don't have that. We'll get to that in a minute. So in this one, there are two different values of x. Well, there's an x outside the brackets and an x inside the brackets. What could those values of x be? Well, the secret is that whatever they are, it has to give a result that equals 0. So, for this, we can already find out that one of these x values has to be 0. And that will be the x outside the brackets. The reason why is because if we have 0 inside the brackets and we add 5 to that, that becomes 5. And then if we have the 0 outside the brackets, 0 times 5 will get us just 0. So we know that 0 will be one of the values. But what about the other value? So we can't just put 0 again. We actually have to figure out what could the value of x be if it was inside the brackets. What could that be? Well, we have to make the value in this bracket 0. So what would be a good value for x? Well, if it's x plus 5 getting us 0, surely a good value for x would be -5. Because -5 plus 5 gets us 0. So the other value of x is -5. And that's how we can factorise by using that to solve for x. Let's do another one, just to be sure. Now, for this one, we don't have everything on one side. So we're going to have to move the 8x to the other side. Now, how do we do that? We're going to be balancing it. So that's the first thing we're going to do. And for this, we're going to be minusing 8x on both sides. So that becomes 2x squared minus 8x will get us 0. So how do we then solve for x? By factorising. We then take what they both have in common. So what does 2x squared minus 8x have in common? They both have x's. So we take the x out, so that becomes x, that becomes 2x, and that is minus 8. We can then see that the 2x minus 8 can also have a 2 taken out of it. So we do that as well. So that becomes 2x. Then inside the brackets is x minus 4. And that will all equal 0. So, outside the brackets, we have to make a 0. How can we do that? Well, we just substitute a 0 in, because what's 2 times 0? 0. And 0 times anything in that bracket will instantly become 0, because anything times by 0 is 0. So one of our x values is 0. What about our other x value? What could that be? Well, if we're now focusing inside the brackets, what could we do to inside that bracket to make it 0? If we have x minus 4 to get to 0, surely a good value for x would be 4, because 4 minus 4 gets you 0. So the other value of x is 4, a positive 4, not a negative 4. And that's how we use it. And that's another example on how we can solve for x. If you're not sure if your answer is right, you might have got a different one, what could be a good way to check? Why don't you then put these values in the original problem and see if it gets you the right answer? So if we have 0, what's 2 times 0 squared? 0. What's 8 times 0? 0. So we know that works. What about 4? So 4 squared is 16. What's 2 times 4 squared? What's 2 times 16? 32. What's 8 times 4? 32 as well. So we know that works as well. It's just a good way to check in case you're not sure. Now let's try a more complicated one. Now let's factorise one like this. X squared plus 9x plus 20. Let's do it. So, firstly, we need to remember that when we're solving it, it will all have to have a problem on one side and a 0 at the other. It does that. Now we factorise. So we have our x squared, so we have an x in one bracket and an x in another bracket. Now, what two numbers add together to get 9, but when multiplied together gets us 20? Well, let's think about it. 20 and 1, well, that adds together to get 21, doesn't work. 2 and 10 adds together to get 12, doesn't work. What about 5 and 4? Add together gets you 9. So, what about x plus 5 and x plus 4? That will all get us, not 2, that will all get us a 0. So now let's solve it. So we have to make sure that in these the brackets equal 0. So what can we do to this bracket? What must x be to make this bracket 0? Well, if it's x plus 5 gets us 0, then a good value for x is negative 5. Because negative 5 plus 5 gets us, you guessed it, 0. So what about this one? How do we turn this one into 0? Well, x plus 4 equals 0. The only value for x that could work is negative 4. Can you notice a trend? Whichever the value is in the brackets, all you have to do is then just swap it round with the negative or positive alternative, and that's the actual solution. It's pretty cool when you look at it. Let's try another one. What about this one? X squared minus 8x plus 16 equals 0. So, we've got them all on one side. Absolutely fantastic. Now let's factorise this. We have our x here and our x here. Now, what two numbers multiply together to get us 16, but adds together to get negative 8? Now, because when we're adding, we're getting a negative number, and because when we're multiplying, we're getting a positive, we're going to be doing two negative numbers in this case. So let's first look at 1 and 16, or negative 1 and negative 16. When added together, that gets us negative 17, so it doesn't work. What about negative 2 and negative 8? When added together, that gets us negative 10, so that doesn't work either. What about negative 4 and negative 4? Well, that added together does get us negative 8. So, we put a negative 4 here, and our negative 4 here. And that will all equal 0. So what would be a good value for x in this one? Well, if x minus 4 gets us 0, then a good value for x would be 4. And then for the second one, x minus 4 equals 0, a good value for x would also be 4. But I've already got a 4 here. And that's all we have to do. We just leave it like that. We don't write 4 twice. If we've already got one value of 4, just keep it as that. And this is the only example of a quadratic equation where the value of x will be the same, where there's only one value. Where if they're the same, we just have it as one value. Simple as. Now, let me show you a more tricky one. Right. X squared plus 2x minus 15 equals 0. Now remember, if we have two numbers that when multiplied together gets us a negative but adds together to get a positive, we're going to be using one positive and one negative number in this. So, let's think about it. What two numbers when added together gets us a positive value of 2, but when multiplied together gets us a negative value of 15? Well, let's do 1 and 15 first. Negative 15 and 1, that will get us negative 14. 1 and 15 and negative 1, that will get us 14. So it can't be either of those. What about 3 and 5? So let's do negative 5 and 3. That will get us negative 2. That doesn't work. What about 5 and negative 3? Well, that does work because that gets us a positive 2. So we put our x's in. And then we put our negative 3 and our positive 5. And that will get us our 0. So what would good values for x be? So what do we do to this x to make 0? Well, if x minus 3 gets us 0, then a good value for x would be 3. If x plus 5 gets us 0, then a good value for x would be negative 5. And that's how we do it. It is simple when you think about it. Now, let's try a challenging one. Now, this is your challenge for today. I've not done this sort of equation before, so let's see how you do with it. I want you to factorise it and solve to find the two values of x. Now, the one thing I will say as a little clue is, firstly, you will have to make all the sides have values and the other side a 0. So you will have to move some numbers around. And secondly, think about what's in front of the x squared. What could we do when factorising that? Good luck. Now, tomorrow's video, we're going to be doing something completely different. We're going to be solving quadratic equations when you cannot factorise. What do you think you need to do for that? How do you think you're going to do it? Do a bit of research, see if you can practice, see if you can get some ideas. And tomorrow, we'll do it. Fantastic work this week, and Algebra Week has nearly come to an end. I've enjoyed it. I hope you've enjoyed it. Let's bring it on to the final episode of Algebra Week.